Thank you. Dobry veche, yek samaj. Uh, that's 90% of my Czech knowledge. So, my name is Mayur. I'm working in Veeam software. I have been a DBA since last 15 years. Initially as a Oracle DBA, then last few years on Postgres. So Veeam does backup, replication, data protection of everything digital, VMwares, Kubernetes, databases. But my work involves Postgres performance tuning and migration from legacy closed source databases like SQL Server or Oracle. So this this talk is related to cloud romance, but I put this in title just to get selected. In reality, it's more of a real marriage. Uh, there is a lot of understanding and mutual understanding is required because Postgres requires CPU, I/O, throughput, and resources, and cloud has limited bandwidth. So uh, it's a kind of a independent relationship, and even though big cloud will paint very rosy picture that this is very healthy relationship, but that's not always true when you look into grassroots, that is your DBAs and developers. Usually coming from your bare metal era to cloud era, you will see a lot of DBAs and developers complain that their Autovacuum used to fly on bare metal, but in cloud it just drags on for forever. Then there are some other like opposite end of it is developer who are just cursing Autovacuum because whenever Autovacuum kicks on a very large table, you will see their application queries dying. So that's kind of a common problem, a commonly seen issue. But before we move into details about this, a few things about the most hardworking employee of any company having Postgres, that is Autovacuum worker. So this is a meme created by Lawrence Albe. So it is true. Autovacuum is expected to work 24/7 and solve all the problems of Postgres MVCC, and then also expected not to step on others. So basically, I'll just quickly give an overview because it's not about Autovacuum. It's more about what problems we are facing in cloud after moving from bare metal to cloud. And usually Autovacuum is very important for removing dead tuples, index cleanups, and updating statistics with auto-analyze, and then updating visibility map, which we covered in last, if you were in Ant Sasama's talk, it was, he also showed that date tuple could be a problematic. And the last but not the least, the most important thing, preventing TXID exhaustion. So this is, it plays very important part in having your Postgres function as it is supposed to throughout lifetime of your project. But it is also very neglected part generally by end users. So few important parameters that we should know for this talk to make sense is what controls Autovacuum throughput, how much I/O it can do is controlled by Autovacuum cost limit, cost delay, and also then your host will have further restrictions. Then also this cost limit gets divided into number of workers, how many Autovacuum max workers you have defined. And Autovacuum work mem controls how much amount of memory is used by each worker. Then there are other parameters like scale factor that defines how when it should be triggered, how frequently it should run. But we know that Autovacuum is I/O intensive, but how much I/O? I came up with this formula from Postgres internals. So maximum throughput Autovacuum can do is defined here. And for PG17 default setting, it could go up to 800 MB per second. That means in practice, you wouldn't see that kind of a number because it will require several terabytes of tables and several Autovacuum worker and very high data volume rate, data change rate, so that you have large amount of dead tuples to remove. And if they are happening simultaneously, then you could hit closer to this number. But even if we hit 1/10 of this number, that wasn't a problem during bare metal days. But in cloud, things are different. Let's see how different things are in clouds. So this is just a question that highlights in cloud your throughput is dependent. Host throughput is dependent on both instance and storage. Both of them control how much throughput a single database can have. And I took from AWS forum because AWS is documentation is most presentable and less scattered than other cloud vendors, but it's kind of a same throughout different major cloud providers. So let's look at how much instance throughput it can limit. And when you see their numbers, there are a couple of things. We saw earlier 800 megabytes per second, and here numbers are in bits per second, so they appear higher. So actually, you have to divide by 8 to get the real number. So at most, you can see it can go up to 2.5 GB per second, and it's very liberal from compute or class point of view. Instance class or instance compute has fairly liberal limit. And also there is one catch with that up to. When they say up to this, that means that burst, they are seeing about burst, and it is available only for 30 minutes a day. So in all practical scenarios, these kind of things are doesn't really help any real application. So the best is to look at the baseline, whatever cloud vendors are providing you, and consider that as a limit. Then second part of what is controlling storage. Storage throughput will put brakes on your overall throughput limit earlier than instance class or compute class. So this is one example for topmost storage class in AWS, IO2 SSDs, and similarly you have different classes in other clouds. So, but if we look at how to reach maximum IOPS or maximum throughput available, how much money we have to spend, then it comes out to be around 26K USD. You can get these calculations in my blog. I will share link at the end of the talk. And this is a calculation taken from AWS pricing calculator. So 26K for one TB of data having 500 MB per second throughput. But that's not, let's not panic yet, because they have another storage class, GP3, which is also an SSD, but slightly controllable cost. It's coming out to be around 477 USD per month, and that's like less for this kind of a throughput. And the difference is that this storage class has lesser durability and more latency fluctuations than the top class, which which will be taken by most of the banks or financial institutes. But in general, this is general purpose free SSD. And I went ahead and calculated for different major cloud providers. Surprisingly, for Azure, it's better. So that's a good thing for Microsoft. It's a calculation for what minimum config you need for achieving 500 MB per second throughput on 1 TB of data. I'm just taking this figure 500 MB as an example. And yeah, so why should you understand cost? So this is a bit over the top. It's not true with EC2s these days. Maybe serverless, if you had serverless. But what could be the real reason? In practice, every day, whenever you have some kind of an incident or top priority incident and everything is down, and as a DBA or as a advanced developer, you increase IOPS for the duration. And then next day you will have a FinOps expert from like cloud FinOps expert coming up to you and why did you increase this? We just have to pay $23 extra for yesterday. So you should be able to answer that. We were having this problem. We saw that throughput was required, and we added, and this is the cost. So that could be one reason you should understand. But what I was saying that in the end, it's all about juggling cost, Autovacuum efficiency, and application performance, because you don't have to give everything to Autovacuum, all resources. Your application needs to run whatever application is supposed to do. So that also requires some amount of throughput. And a picture says 1,000 words, but I would prefer 1,000 words worth of time. Let's see, we can answer a few of the questions that previously DBAs and developers were complaining. And I can zoom in. Okay, yes. Zoom in is working. So let's start from the first problem. Autovacuum on a large table is causing application queries to time out. That's a kind of a common developer complaint. So you should then look into whether host has enough, both on compute and storage side, has enough capacity for Autovacuum and application queries. So how do you know about application queries requiring throughput? You should know by doing load testing prior to going live in production. Or you should have some kind of a benchmark. It's your own application. And for Autovacuum, you can calculate using the formulas previously provided. So answer is no. Then increase your host throughput or dial down Autovacuum cost limit on that particular table. So it's possible to set those parameters at table level. You don't have to set parameters at instance level, but if you set it on table level, then it will be applicable for those tables. You can also reduce frequency of Autovacuum by adjusting that particular table's scale factor. And does it solve? Yes, then it's all good. If no, then probably you need to do something innovative. Consider partitioning, dropping unused indexes, or even query optimization. Yeah, that's like a last option. You can't. I mean, you can't say that Autovacuum shouldn't run. It's doing a lot of things for you in background, and it's good for long-term health of Postgres. So you have to cut corners somewhere. You have to give. It's always about trade-off. And if it solves, then it's okay. But then again, you come back here. Does host has enough throughput capacity to cover both Autovacuum? If your answer is yes, and you're still having problem, better calculate, because it's true that in cloud you will get what you paid for, but what you are paid for is not very clearly defined or clearly, it's not in your face. You have to run through fine prints and find out. So it might be calculation problem. So do that calculation again and see, and then do rest of the steps. So that's for first problem. Let's move on to second problem, which is quite common. Autovacuum runs too long, and in bare metal, everything was working fine. When Autovacuum was working fine, everything was working fine, because that's the general trend. And in Ant's case, he even quickly shows when dead tuples were not getting removed, how quickly PG benchmark performance went down. So that was a good example. I should include next time in this as well. So if Autovacuum is running too long, what should you do? Then again, same question. Does host has enough capacity? Is this kind of a question you should have answer to for very critical databases which are in production? And then if answer is yes, then you have to see whether cost limit is defined properly, or all the Autovacuum parameters are defined properly, because in general, Postgres parameters are very conservative. So, or even cloud providers may have their own set of parameters. There was one talk about performance benchmarking. In that, you could have seen that for default parameters, there were some unexpected result from cloud vendors benchmarking. So that could be one of the reasons, because everyone will have their own set of parameters. So you just check them, it's all fine. If not, then increase it and apply at table level. Yeah, whenever you do these kind of things, you should target the root cause, the root problem, the root table, instead of applying just like liberally everywhere, and then everything is costing you 10 times more next week. Then again, FinOps expert will come, and then you won't be able to answer him. Like we could have just gone with table level increase. Does it solve? Yes, solve. Then you're happy. No, then I'm not happy. Yeah, then you have to again calculate host throughput mathematically and check again. If the answer is no for your, then step is similar. You have to increase host throughput and also increase cost limit, because it might have been lagging for a long time and not cleared a lot of things. And then the third question which we did, if there is a long running transactions or abandoned replication slot, they will prevent from Autovacuum dead tuple cleanup. So for that, it's pretty simple. You just have to remove those long running transactions, or do performance tuning for SQL tuning, or any abandoned replication slots, then drop them. And rarely you will have that question like not enough Autovacuum or workers, but that happens when you have a database, when you have a Postgres cluster with multiple databases. Because Postgres Autovacuum worker parameter is at cluster level, and its very default value is very small, 3. And I have seen some of the clusters with thousands of databases in same cluster, and then you have thousands of databases with maybe tens of thousands of tables, and just 3 workers. It's like, it's not a fair competition. So you need to have more Autovacuum threads in that scenario. If it solves, then good. If it doesn't solve, then repeat the thing. So this was about that. Yeah, this stuff. Then some of the low-hanging fruit we can easily target is Autovacuum work mem. It's like, if you have good enough memory, you don't have to do a huge amount of I/O. So similar thing is here applicable, but how do you decide what should be Autovacuum work mem? That is also, I have used the formula, and it's derived from common logic that your memory will be taken up by sessions, your memory will be taken by buffers, shared buffers, and there will be some OS memory, OS cache. And in this example, I just took one 64 GB instance. 64 GB is not too much these days. But you in cloud, you will have very tiny instances with 4 cores, 2 cores, and 4 GB RAM, and it's like it's even lesser than my phone right now. So these kind of instances will have a problem. So you have to calculate for them. And this 1 GB cutoff is because of this. It is PG17, and it's in hard coded in Postgres code. After Postgres 17, this 1 GB cutoff is not there. That means Autovacuum can use more than 1 GB of memory. And in Postgres 17, it uses more efficiently than previous version. So maybe you can still use the same formula. And this is my favorite part, when there are budget constraints. That's the time when DBS get to shine. So you have to think creatively. You have budget constraints, you have very tiny cloud instance, and you have a huge amount of data, large amount of users. So you should start with targeting things like partitioning problematic tables, not all tables, because partitioning is also coming up with cost. If you don't have a reason for partitioning, if your queries are not having partition clause in their partition key in their where clause, then you could see a lot of lock manager events, lock manager wait events, or LWL locks, and it could take down your application. So partitioning has to be done with some kind of a sense, and because of that, your size of data and size of indexes reduces. Autovacuum cleans up the data and indexes. So smaller the size of data being targeted, it will do lesser I/O. It will be more efficient, more quickly finishing. And then drop and detect and drop unused indexes. That's really common, because Postgres vacuums all of the indexes every time, every run. So if you have a table with say 100 columns and 80 indexes, no real application is going to use those 80 indexes. It might be few of the unique columns which are being used in your queries, but your design was from the start was such that you have large amount of indexes present, so you could get rid of them. Even if it could be a trade-off between having a slightly lower performance for some of the queries, but still on long term it's more beneficial. And then minimizing long-running transaction. Yeah, so long-running transaction block Autovacuum dead tuple cleanup. So that's kind of a it was shown in Ant's lecture previously in actual use case, where a long-running session he created using a repeatable read, but it was not cleaning up dead tuples. So this is a very common problem with hybrid databases. That means your database is OLTP, but it's OLTP only on paper. You will have reporting queries running on the same. You will have mixed workload. You will have different analysts coming and trying to directly query large things. So pure OLTP doesn't really exist in reality. You will always have some kind of a mixed workload. And mixed workload is dangerous because of those long-running transactions. If it still is impacting your performance, then you could dial down on cost limit and increase cost delay, Autovacuum cost delay, because that will reduce IOPS done by Autovacuum. And this is kind of a last stage thing, because if you do that, then you have to place some kind of a early warning system for TXID wraparound. AWS has a great document on this, how to create this early warning system for TXID wraparound. TXID wraparound means that Postgres transaction ID is 32 bits, so you cannot have more than 4 billion TXID. So whenever it reaches close to that limit, everything will shut down, and your server will not accept writes. That's why it's very important for Autovacuum to kind of continuously keep running. So, and this early warning system can be found by just querying PG catalog tables. You can find out the age of particular tables were TXID, and you will be able to find out which table is coming closer to the limit and take action accordingly. Yeah, last one. In upgrade PG17, it improves overall vacuuming. And then there are two different types or different types of approaches depending on what is your database. Is it a pet database or is it a catch-all pet means? Is it a special EC2 that only your team is handling, or you have like thousands of databases, thousands of different database servers? When I said databases, it's like mostly different servers managed on maybe RDS, like cloud managed, or even you could have thousands of EC2s, but that's like a whole lot of pain. But the approach will be different. If you have thousands of tiny cloud databases, then you don't really have those compute and storage throughputs, because as we saw earlier, throughput depends on both instance class, compute class, and storage type. And for tiny databases, generally people use smaller instance classes, and they don't have that throughput capacity. So for this kind of a small, large number of RDSs, you don't want to investigate each and every one of them scientifically, calculate everything. That's just humanly impossible. Then you will have hundreds of DBAs working in same team. But generally, there are very few DBAs and very large amount of databases. So for them, some kind of a early warning system for TXID wraparound needs to be implemented first. Then you can log Autovacuum mean duration and do some kind of a log mining. That means your Autovacuum is taking 1 hour and you are fine. Nothing is breaking. Your database is tiny, but when your Autovacuums are taking 12 hours, then you start panicking. Something is going to break. So at that time, depending on your application behavior, you could set some reasonable duration and start mining it. Like if you have few tables which are exceeding that limit, you get alert and then act accordingly, set parameters for those tables specifically, do manual vacuuming, whatever action is possible, and increase cost limit gradually on the need basis. If you are getting too many of such alerts from your logs, then you could do a gradual increase. And for paid databases, everything is simple. Not simple, that means everything is interesting. You have to calculate using previous formulas, and you can get an optimal value for your tiny pet EC2 or self-hosted. And then this, like, John Lennon was a Postgres DBA. This is working class hero is designed to describe Postgres Autovacuum to layman or to anyone without any Postgres knowledge. So it's true that as soon as Autovacuum worker starts working, they made it feel small. So people don't give it time or cost limit, cost delay as much as it should require. And till the pain is so big. Yeah, that's like pain becomes big gradually. Your data tuple starts piling, your databases, your indexes getting fragmented, and then your queries getting performance start decreasing. And overnight, you can't expect to change maybe 100 million lines of code and improve it suddenly. But when it goes down this way, pain will become very large, and your management or your customers, they will demand you to do something at the end of the like when you're at the edge of this pain. So this is working class hero. Yeah. And these are the references. Some of this Percona blog discusses Autovacuum internals. It also discusses the thing where I derived that formula from, and then pricing calculator for different cloud vendors. I have to say, I did not include Oracle's cloud. It's not considered that major, and still, even if it is better in terms of pricing and IOs, I don't want to get involved with lawyers, so no. And thank you. And this is my, this talk is converted into block format, where you can see those calculations in detail. So if you need it afterwards.
Okay, thank you a lot for this talk. Some questions from the audience? Okay.
Yeah, it's half question, half idea, because we had several customers who, complained badly about Autovacuum, how it is, doing all these problems you described. And when we dived into their Postgres logs, they had very bad design patterns, like tens of thousands failed inserts on constraints per minute, each in separate transaction, which of course created a lot of bloat in the database, and that transaction ID was like skyrocketing. But it was the fault of Autovacuum not coping, with these bad design patterns. So maybe it would be also interesting idea, to expose these bad design patterns, because that was like really very strongly visible that the worst implementation, the more they complained about Autovacuum. Otherwise, I really enjoy your talk. Thank you very much.
Thank you. I have experienced same in production systems of my one of previous company, where design pattern was such that you use unique violations to avoid duplicate insert, but you were providing application ability to keep on inserting whatever 10 minutes ago data, or maybe one hour ago data, or whatever data you want to reinsert, recalculate. It was possible, but because of that design pattern, we had around 13 TB of a table, ledger table, financial general ledger table, and out of 13 TB, 8 TB was bloat. So it's just because of that pattern, and for a long time, this after moving from bare metal to cloud, for a long time, this Autovacuum cost limit and cost adjustment were ignored. So like everything worked in combination, mixed workload, that bad design pattern because of unique violations, and the solution was very simple. Instead of those kind of a unique violations to avoid duplicate insert, just to use something like insert on conflict, do nothing. That will avoid creating that tuple in its first place. So, but we found we did logical replication and upgrade of that database and found that database size reduced significantly from 35 terabytes to 18 terabytes. So that much amount of bloat was present in everywhere. So that's a good thing. I'll add it, but here my focus was to show hope that your takeaways in cloud, you get what you paid for, but you have to see, you have to verify what you are actually paid for. And Autovacuum is your friend. So that's a couple of takeaway. Thank you.
Okay. Any other?
One of your advice was to get rid of unusable indices. It is, of course, very reasonable, but in practice, I think it is not very easy. So the first question is, does Postgres somehow support to recognize which index is used and not? Or how would you proceed if you, in an application, want to find indices that are not used?
I think in Postgres catalog tables, there is you have tables which are going for sequence scan, pgstat tables, some things which are going for full scans, which are how many index scans are happening. And also there is a way to determine whether index is used or not. I'm right now thinking of developing an kind of an extension that looks into, like I was going other way around. Like I was going for finding out the sequence scans and create indexes. But I think this is a better idea to look for something and drop it by itself concurrently. But there is a way.
Okay. Any other question? Then that's the final. Thank you for the talk.
Thank you.